Hello everybody and welcome back to the Ace Simulations channel. Today I'm going to be talking about this rocket. My goal with model rocketry is to be able to fly a rocket faster than Mach 1. Mach 1 is defined as being faster than the speed of sound, and as a result, fly a heavier rocket like this, that's maybe a kilogram or 2 kilograms, I will need to be flying a high power motor. This rocket I've been working on for the past couple months, and my last video on it was just early stages development with the flight computer and ideas. But since then, I've actually built the entire rocket, installed all the avionics, and I'm getting ready for the first flight. In preparation for the future high-power rocketry launch, I've been testing small-scale components, looking at various components and pricing out the entire thing and looking for funds. However, that's still a little bit of a ways off because, like I said, I want to be testing this rocket. Since my future goal is to go faster than the speed of sound with the model rocket, I need to begin small-scale testing with a simple and cheap rocket. Enter Jank Squared. Jank Squared is designed to be a super simple and cheap rocket that I can use to test the components. It has a complete avionics suite, which I'll talk about in a little bit, and is manufactured from various other rockets, hence the name Jank Squared, and I'll explain that in just a minute. Additionally, since it's a simpler and lighter rocket, it can fly on smaller motors. So this rocket is flying on an F20-4, which is this motor right here. So they're fairly cheap. I have a bunch of them lying around, and so it made sense to be able to do that testing with this rocket. So the reason it's called Jank Squared is because the first stage, which is here, is made out of my old rocket called Janko. Janko was used to test this computer. It's kind of taken apart now, but it would deploy brakes on the way up to control its apogee. The second stage, however, is made out of another rocket called Eggplant, and this is another part of Eggplant. This was a rocket that was used in the American Rocketry Challenge competition in 2022. And the second stage of it is up here, and that's what I decided to reuse. So between those various components, and it also has like a new nose cone, for instance, it's just a very janky build due to its kind of pieced together nature, hence the name Jank Squared. So the future goal of launching a high-power rocket faster than Mach 1 needs to begin with a super simple and cheap rocket. So building this rocket was fairly simple because it was made from a couple of other already manufactured rockets. The nose cone is an ogive nose cone, and this gives a smooth transition to the body tube and improves the aerodynamics of the rocket pretty substantially. To prep the rocket, I sanded everything down, improved the structure in various areas, and then gave it a nice fresh coat of paint. On the second stage piece here, I also had to cut out the areas for the avionics access port, and then also the holes that are needed to mount everything. To paint the rocket, I really wasn't sure what I wanted it to look like, so at first I just gave the entire thing a black coat of paint. I was using a combination of a primer and spray paint, so simplified the painting process. So the black paint job I thought looked cool, but I thought it could be a bit better, so I pretty much completely winged the rest of it. I used a whole lot of blue masking tape and masked off kind of this symmetrical pattern on the base, and that I painted everything down, including the fins, white. I think it turned out really nice, and another little subtle thing I was able to do was painted the launch rail adapter pieces here, alternate colors, so the top one's white, black one's black, and I think that makes it look really sleek and really nice. Alright, let's talk about the elephant in the room, the avionics. So you can see these avionics are pretty impressive. It's kind of been iterated a lot over time. I began with some super small avionics suites, which were very simple and just very prototype, and I've built it up to what I have now. The main processor on the rocket is the Adafruit M0 Adalogger. This features the M0 processor, which is really fast, and it also includes a microSD card slot for data logging. Along with that, it is able to be powered off of a super tiny 400 milliamp battery, and also has multiple different lights for indicating various flight modes. For the altimeter, I'm using the Adafruit BMP388 altimeter. This has a barometric pressure sensor and temperature sensor combined, and is really accurate. It's accurate to I think about a quarter of a meter, which is pretty good. So for the IMU, I'm using the Adafruit B&O 055 IMU. This is a 9 degrees of freedom IMU, and it features just about everything possible. It's got magnetometers, accelerometers, and gyroscopes all in the X, Y, and Z axis. Additionally, it has another M0 processor on board, and it does sensor fusion on the board so that when I pull data, I can get them in Euler, Quaternion, basically whatever I need to do my math, and it's an excellent board. I highly recommend it. So all of this forms the basic data logging suite. However, I also have live telemetry available, and this is super cool. So in the rocket, I have an antenna right about here, and that's connected to an NRF24 transceiver. The transceiver is running at 2.4 gigahertz and a data rate of 250 kilobytes per second. This allows me to get a sensor sensitivity of about 94 dBm. I have the output power of the transceiver set to the maximum, which is 0 dBm, and this is able to give me a range a little over 1 kilometer, so more than what I need, and it's extremely reliable connection as well. So the full Avionics suite will combine all of its various sensors into one data structure. This data structure is then transmitted down to the ground station, which is made up of this computer here. It's an Adafruit 32U4, also connected to another NRF24. It's running at the same specs as the one in the rocket. And this computer will take the received packet, decode it, parse it, and then it sends it through USB serial connection to the main computer here. This computer then, through Python and HTML, CSS, JavaScript, a whole bunch of other languages like that, will then take that data and display it on a web interface. This web interface is super cool. It can be broadcasted to any computer on the network, and it will display the main sensor information coming from the rocket, and it also has local weather and a really handy go-no-go display panel. All of this stuff is completely custom made, and may release some of it at some point, but we'll see. I'm not really sure yet. I am going to be releasing a future video, which is going to be a deep dive on this rocket, including all the avionics, engineering, and software that I'm using. So if you're interested in that, make sure you subscribe. I'm super excited about this project, and I'm really looking forward to its first flight in the upcoming months. It would be super cool if in the next 5 years or so I can do a high altitude flight, all high power of course, with this avionics suite and a bunch of cameras. That would be super cool, but we'll see if we get there. I know this video is a little bit different than what I normally post, but if you enjoyed, consider leaving a like and subscribing. It really helps support me and gets me through the YouTube algorithm. I'll be posting more videos about this project as I continue working on it, and I kept this one fairly high level. It didn't go into very many details, including like the different CAD modeling and specifically what I'm doing here with state machines and whatnot, but I'll be having a future video come out on that. Most likely it'll come out after I do the first flight and I'm going through data analysis, so make sure you stay tuned for that. I hope you guys enjoyed this video, and I'll catch you guys next time. See ya!